Alright, hello. So, I'm actually very excited to show this piece of code. Let me zoom in. I actually have been watching my videos back and seeing how I can improve them. So, this piece of code I just finished writing, literally about 30 seconds before I'm making this video, and it's not fully done. Like, it's done and everything that I want, and it works and does what I want. But there's definitely stuff that can be added. But this is actually a very like I wouldn't call it complex, maybe it is, but very big piece of code. It's not the most simple thing to understand, but it is super cool. So let me show you guys this. It's a intergalactic simulation of like a civilization trying to find habitable planets. So let's actually run this and show you guys. So first we have to choose how many members we want on the ship. So we'll just do like 10. So first we get this. Hello, Captain. You're in charge of providing shelter and searching for a new home for the human civilization. Your ship's on course to exit the Milky Way galaxy and enter a wormhole that will put us near a habitable planet. You must keep the crew healthy and happy while searching for our new home. Then we have the menu here. So as you can see, we have this art. We have day 1. We have our ship health, ship fuel, ship food, distance traveled, which is 0 thus far, and then our list of crew members, their location, their health. They have IDs, obviously, their hunger and their happiness. And then we have options here. We have a farm. We have an incubation chamber for fuel. We can feed our crew. We can view past planets, and we can watch movies, or we can repair the ship. So first, we'll just view past planets. So as you can see, the only planet we've passed thus far is Earth because it's Earth. We have gravity, which is the gravitational constant, the survivability, which is survivable, atmosphere 1, water 1, soil 1. So these are the integer values for the survivable factors. All of these are 1. This is survivable. So we'll continue. Day 2, you can see we've moved 16 million miles now. Obviously, this is a futuristic ship moving very quick because that is not something we can do current day speed wise, but you can see each person lost some hunger, lost some happiness. So we'll watch movies. Dust storm is ravaging Earth. We're barely able to grow crops anymore, but we can see that happiness did get boosted from it. But we can see our fuel's also going down. So we'll send some troops to the farm. Welcome to farm chamber. Crew member 0, seed count 0, food count 0, incubation time 0. So we'll send crew to the farm, and we will send 7 troops to the farm because we have 10. 7 crew have been sent to the farm. We have 350 seeds, but our ships also encountered a gravitational disturbance which caused 40 damage. So you see we just took 40 damage. Our fuel's still being used each iteration, and we have this much food. Our hunger's starting to go down, but not down too fast. So we'll go ahead and we'll repair the ship since we just took some damage. And I guess we should incubate some fuel too. Let's send our remaining, as we can see right here, ship farm. So we only have 3 available, so we'll just send our remaining 3. So now we have all of our troops in either the farm or the synthesization. Can't say that word, but the chamber for fuel. So we'll go ahead and watch a movie or something. The Office starts playing. The crew likes it. But now we see we're passing Mars. We see Mars has a gravity of 3 point blah 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 blah. It's unsurvivable. We see the atmosphere is a problem. The water and soil is there. So we can see in the farm. Let's take a look. Incubation time 0. So that means the farm's done. We can return the troops. So now that food is added to our stuff. Let's actually feed our troops here. Let's feed them 40 each. Why not? So our troops are not very hungry anymore. They are pretty good. We'll go ahead and return from the chamber for this too. And we need to... Oh wait, no, our fuel just went up. Yeah, because we returned it. So as you can see, it's pretty cool. View past planets. We'll see we've passed Earth and Mars thus far. We've traveled 220 million miles. Let's watch some movies. Trying to kind of speed run through this here. So now we can see we passed Jupiter. We have Jupiter now. It's unsurvivable. We'll view past planets. We can see we have Jupiter and stuff. And we've encountered a gravitational disturbance causing 40 damage. So we should repair the ship for sure. We actually need some fuel too. So let's send some troops to the incubation chamber. Let's send 8. Yeah. Let me see. So incubation chamber. Crew members 3. Passing sign. So I think there's actually an error we have to fix here. But that's some of the basics of the code. We'll take a look at that right now and actually fix it because I just finished this. So any errors we encounter are errors that I am also dealing with like as I make this video. So the error we were having saying that there's no troops to return. So it looks like we never reset this to 0. That means for the farm, no, we did. Okay, well that should fix it, but let's go over the code now. So we have included in main IO stream, list, random, C time, F stream, O stream, ship.h, crew.h, planet.h, farm.h, and fuel chamber.h. So first let's go ahead and take a look at the building blocks of main. So we have this function here, menu. The options are enter farm, enter this, feed crew. You already saw them when I ran the D. So now we have display art. This takes a string file, has a string art that's empty, opens up an F stream, opens up the file. While it's not the end of the file, we get line, put it into the string art, then we output it in end line, and we close it. So this is just for the art display. So we go in our main, and first we create our ship. Not a pointer, just our ship. Then we have bool alive. This is used later on for checking in the bottom of the loop to make sure that everyone is still alive, or the contingencies for this program to keep running at least need to still be happening. So now we create a pointer for crew, and then we need to create our list of crew in main. So first create a pointer called new crew for crew, create a list of crew pointers called crew list, and then we have an iterator set for that now. So now we get the value of how many crew members the program is going to create. We ask the user, we get it, system clear just to clean it up, then we use this to create it. So we just have a simple for loop that goes to create the new pointers of crew, sets the ID for the crew as I, then pushes it to the list in main, and then we also have a function in our add ship, in our ship ship.h header file that pushes this pointer into the list in ship. So let's actually take a look at that now. So this is our ship.h basically overall most important header file out of all of these. So you can see we have health, food count, fuel count, distance, and then a list of crew. So the function add crew takes a crew pointer and then it pushes it to this list. So now in main we have our master list of people, and then crew or ship also has access to those same people. So this just is oops, what'd I do? Here it is. Okay, this right here is just outputting like the plotter, just a little C out, and then we pause and clear. So creating Earth, we just create an instance of the object Earth. We set the info for it. Then we create a list of planets we've encountered. So far it's only Earth, so we push Earth. And we have a character E that we use inside of the while loop to iterate as we encounter new planets. So this will become more important later on. But this back to the ship.h. the functions we have are display, add crew, then the get and sets for everything, feed crew, watch movie, check crew. We'll go over these later. They're pretty simple, but we will go over them later. So now we create a farm and we create our fuel creation chamber. We just create instances of them because there's only one. There's no reason to make pointers. And then we have bool on farm is equal to false, and then bool on fuel is equal to false because there's no one in there by default. We have to put people in there, so they're set to false. We come down here and we get the random generators. So we just create a default random engine, and these are important, right? So these two are used for the distance the ship travels each time step in our while loop. So for the first, I think it's 400 or something like that, I have distances traveled. This is one use. Afterwards, this becomes used because the distance between planets becomes a lot larger. So each iteration, fuel loss is somewhere between 10 and 25. This is a generator for that. This random generator is for health and hunger. So if hunger is below 0 or whatever, then health goes down by this, and each iteration hunger goes down by this. This is a random spinner 1 through 8 for the dialogue that pops up when you use the watch a movie switch function. This is a chance of winds affecting the ship and damaging it. So it's a 1 in 10 chance, 10% of each iteration of winds like damaging our ship. And then this is a planet generation thing, which is used way later on. It's a 1 in 5 chance of us encountering a planet each iteration of the loop once we enter a wormhole. So don't worry about this yet. And then this is a damage done if this occurs. It's somewhere between this and this of the ship. So now we start the loop. This is inside the loop, so I just declared it before so we don't constantly redeclare a variable. So we start the loop and we have day equal to 1. We start it with some random character. So while it's not equal to x, obviously this is not equal to x. So first we display art, ship art.txt, which is just this. Take a look. It's just this right here. Then we output day, the day, which is right here. And then we do our ship.display. So let's take a look at that. The display declaration's here. So if we come up to display, we see we have our function here, and it outputs the ship health, the ship fuel, and the ship food, which is all just data that's in here. And then distance traveled, of course. And then we go ahead and we output the crew list. So we have an iterator that is set to the beginning. While it's not equal to the end, we call the display function for each person in this list of crew members and then increment. So we'll take a look at the display for a crew member now, and we'll take a look at the data for it too. So each crew member has this data. They have ID, location ID, health, hunger, happiness. So their ID is set in the beginning, and there's no reason for that really other than making sure people know that they're different people. The location ID is a location on the ship that they're at, or if they're alive. If they're dead, then their ID becomes 3. So health is just their health, hunger, same thing, happiness, same thing. And if we come over here to the display, we have a string, location string. If their location ID is 0, which is what they're all set to off the rip, they're in the main hall. If it's 1, which we have to move them there, then it's farm. If it's 2, they're in the synthesization chamber. You can't say that word, I misspelled it too. But if it's other than that, which would be 3, for instance, then they're dead. And then we just output crew member ID, location, health, hunger, happiness, and that's the output for that. So each crew member gets their info displayed from this function inside of ship.cpp. So that's what this does. So this is just displaying the info to the user. So now we come down to the actual stuff in the code, the switch. So we have a switch that takes a menu. If you guys remember the menu at the top, we'll take a look at it real quick. A, B, C, D, E, F, and X just ends the program. So if they choose A, which is the farm option, then we just tell them, welcome to the chamber, and then we output the current crew count, etc. So it should be 0 if there's no one in there. Then food count, incubation time should be 0. And the options are to send crew or return crew. So we go ahead and we create another switch off the character val1. And if they choose send crew, first we check if on farm is false, which this is set to false by default. So this will be false the first time that someone tries to send someone to the farm. So after it does this, how many crew members would you like to send to farm? We go ahead and we get the crew members. We have a counter equal to 0, and we iterate through the list, and if the counter, which is set to 0, is less than the amount that we need in, and the location ID is 0, which means they're in the main hall, then we set their ID to 1, which moves them to the farm, and we increment this counter. So basically, once this counter reaches the amount of people we're trying to move to the farm, this will stop doing anything. It'll just iterate through the rest of the loop and finish this, and then it won't affect anything wrong. So now we set the crew count of people on the farm to the counter, which is the amount of true people that were moved to the farm, because they're inside of this. And then we go ahead and we check if the amount of people we wanted to be sent, which is crew farm, the CN amount, is equal to the amount that's actually been sent, the counter. And if it's not, then we just tell them, okay, you didn't have enough available, just to kind of tell them. We'll fix that right there. This should be space too. So we go ahead and set the seed count to seed temp, which is generated just by counter times 50. And then the time value is randomly generated. I think it's like 3 to 7 or something like that, or 3 to 5. So it's 3 to 5 days that it has to incubate. And then incubation time is this. So incubation time, we take a look at that. Let's take a look at farm.h and farm.cpp. Incubation time is just an integer along with this other data. And if you look closely, there is an incubate function. So let's take a look at that. The incubate function simply decrements the incubation time, which was just passed in the main file. And if the incubation time is less than or equal to 0, then we just make sure it's still equal to 0 so it looks prettier. And then we take the food count, and then we add the seed count to the food count, and then make the seed count 0. So after the incubation time has reached 0, essentially seeds become food, and then the seeds become, like, that's it, they're gone. The seeds become food and the seeds are gone. So after this is done and we set the incubation time to the value that's been passed in from this generator, we tell the user how many people have been sent, how many seeds were created, and then we set on farm to true. So next time anyone tries to do A, like, you know, the A inside of welcome to farm, it's gonna just output crew already on farm because this is set to true. And this is only gonna run if it's equal to false. So case B is if on farm is equal to true, which is what this is returning, then we output the information display, on farm display. Let's take a look at that. It simply outputs crew amount, seed count, food count, incubation time. And then if the incubation time isn't equal to 0, then the seeds haven't been incubated yet, so they can't return them. Otherwise, it sets it equal to false and sets the seed count to 0, sets the crew count to 0, sets the food count to the old food count plus, well, it should be, no, this is right. It's our ship.get food count plus our farm.get food count. We haven't set the food count of the farm to 0 yet until here. And once the incubation time is set to 0, it takes care of the extra setting and getting for us right here. Food count equals food count plus seed count. So we don't have to do that. So let's come down here, and it just goes through and it gets the ones that were on the farm and it returns them. So that's what that does. And if, obviously, if on farm's not equal to true, it's just going to say there's no crew on the farm to return. That's it. Otherwise, not an option. And that's it for the farm. The fuel chamber is the exact same thing, but it's just the fuel chamber.h. It's the exact same display, incubate. I'm not going to go over this again because it's the exact same thing. but it's just for fuel. Um, it's just slightly different syntax because it's for a different header and .cpp file and different data, but it's all the same code. So we'll come down to feed crew, which is our next menu function. So basically this function is solely inside of ship.cpp. So we ask the user how much they want to feed each crew member, and we get it. And then we get the crew size from the crew list.size. And then the attempted feed is the value they want to feed each troop times the crew size. And if the attempted feed is greater than the amount of food we have, then it just tells the user we don't have enough resources for this. And if it isn't too much food, then we just go ahead and we take the food count and we set it equal to the food count minus the attempted feed, which is how much they end up feeding. We create the beginning of the crew list, and then we iterate through, and if they're alive, if they're not equal to 3, then we go ahead and we set their hunger to what their old hunger was plus the amount they fed each to troop, and then we iterate it. So that's it for this function. We come down here to the showing planets encountered option. We just start a planet list, and then we read through it, and while it's not the end, we display. That's it. And for this one, probably easiest thing to understand, it just takes this movie generation value, the 1 through 8 dice roll at the beginning, has a switch, and it just see outs these statements, and then does watch movie function, which is simply iterating through, making sure they're all alive, and if they're alive, we just add 6 to their happiness. And then it, outputs this. So it's pretty cool. These are like movies I enjoy, so that's why I put them in there. Obviously, I like Interstellar a lot more than, like these are still really good. And then if we go to F, this is repair the ship. If the ship's at this health, there's no further repairing it. We don't want the ship to just be spam repaired. And if it's under that health, we just randomly generate a repair, and we add it. So that's it for the options. So if we come down here, we get the stuff that makes this keep running. So we go through the crew list. This is our master crew list. This isn't in any ship, any crew, any fuel. It's just in the main while loop at the bottom. So we start this while loop, we iterate through, and if their location is not 3, which means they're alive, then we generate a random hunger, we generate a random happiness, and we set their hunger, their old hunger minus the hunger they lost. And the happiness, the same thing, minus the happiness they lost. So now we get to the conditionals here. If their hunger is less than 0, we set their hunger to 0 again, and then we also set their health to their health minus the random hunger value that was generated here. And then if their health is less than 0, not their hunger, their health, this is if their hunger is less than 0, if their health is less than 0, we change their status to dead. And then if their status is dead, you can't put them in the farm or stuff like that. So if we go here, if the happiness is less than 0, we just set happiness to 0. And this is something maybe I can do more with later, but for now I think it's just cool to kind of be trying to keep your crew happy, keep your crew fed. There's no really negative repercussions of the happiness being 0, but I mean, you don't want your crew to be miserable. And we iterate through the list, and then we come down here. This takes care of the crew for us. This whole piece of code right here slaps the stuff we need to be downgraded on the crew each iteration so that the other stuff is necessary. And then planet encounters. So this is a part that I think is really cool. So basically, if our distance is over 100, which is 100 million miles, then we encounter Mars. So we go ahead, create Mars, we set the stuff to it, and we push it into our master list, say passing Mars, and we display it. Then we set this character, planet C, from E to M now. So now the next time we pass this many, this will be the thing that runs. Same thing with Jupiter, J. Now this will run after this distance. And then S, so now this will run. And then U, so now this will run. And this is a cool part. So we approach a wormhole, we display some wormhole art, which we'll take a look at. It's actually some super cool ACI art. So it displays that art, and then we pause and we clear, and it says the wormhole is warp time and space took us to a new galaxy. Whoa, we're in a new galaxy. And then we go to the next one. This next one has no distance parameters. It's just this character, which is now it's permanently set to. So now we spin this dice, 1 through 5 planet generation dice, the one I said we'll get to a little bit at the beginning. And if it's equal to 1, which is just a 1 in 5 chance, new planet becomes created. And then we say we're approaching a new planet, we display it, we ask the user what to name it, get line it, set the name, push it to our list, and we go ahead and we check the overall survivability of the planet, and if it's equal to 1, which means it's all survivable, then that's the end of the game. But let's finish looking at this real quick. Yeah, we'll look at the planet first, actually. So, because I don't think I've showed you guys the planet file. So, we have name, gravity, survivability, survivable atmosphere, water signs, soil signs, overall survivability. So, this is the only complicated part about planet. We have random engines here. Each time you create a planet, it generates this stuff for us. We don't have to set it in main. We get a random water value 1 through 5, a soil value 1 through 4, an atmosphere value 1 through 4, and a gravitational generation 1 through 20, decimal, which is just random. And this part doesn't really matter, but these three, if all three of them equal 1, then we have a survivable planet. So it's a 1 in 5 chance. So the true chances of us running into a survivable planet, if we calculate it, let's take a look. 0.2 based on this program times 0.25 times 0.25. So we have about a 1.25% chance of one of the planets that becomes generated being survivable. But it's still a chance, and if one happens to be generated to have all values of 1 for their data, then it's a survivable planet, and we output survivable right here. So that's how this works right here. Yeah, overall survivability equals 1, and survivable planet we win. So the win chance, this is just a random 1 through 10 generator at the beginning. If it's equal to 1, doesn't matter what number this is, just 1 in 10 chance. Then we get a damage, and we tell the user has been damaged under the ship, and then we set it, and that's it. This is the last bit of the code that really matters, and it's what helps the farm and the fuel run. So if on fuel, which means if there's someone on the fuel incubation chamber, which will become set to true once that function gets called, if you remember, then we go ahead and we start using the incubate function, which is just the decrementation of the time which is passed into it. And then once that's equal to 0, it's done. So if it's false, this is not going to happen. So it's not, doing anything wrong. Same thing with the farm. It's the same code, but for the farm. And then this right here is for the distance generation of the ship. Each iteration of this loop, the ship travels. So while the ship hasn't traveled over 350 miles or million miles, the distance generation is a generator 1, which is kind of small. It's this one, 15 to 30. After a while, we want the ship to travel faster, so we start doing the number 2 one, which is 60 to 120. Then we set our distance to the old one plus distance. Fuel loss we just get from the generator, and we take it from the ship, and we increment the day. And this checks to see if the crew at least has 1 living troop, fuel on the ship, and health on the ship. So this is a boolean right here. Alive is a boolean that's set to true by default at the start. If you remember, right here, right in the beginning, right below ship. So it all comes connected. Let's go look at this function. Check crew right here. So we have a counter set to 0. We start our crew list, and if the location ID is not equal to 3, so they're either in the main, on farm, or in the fuel chamber, we increment this, and we increment through the list. And if the counter is more than 0, so there's at least one person alive, the health of the ship's over 0, and the fuel count's over 0, we return true, so it's all good. Otherwise, we return false. So, if this is not equal to true, we failed our mission. System pause, inputs equal to X, breaks the loop, and then it just system pauses again, system clear, and then it just breaks the program, returns 0. So, that's it for like the code breakdown. I mean, there's not much more to go over. I'll go ahead and scroll through it slowly. The entire main. We'll go from file to file. I just finished this. It took me about 3 hours to make. I mean, not too much time, but it's pretty cool. I mean, I think it's pretty cool. So, it scrolls slowly. Definitely could have made maybe the list of planets using pointers or something like that. I tried to, but it seemed kind of pointless to do that. There's no need to really. There might be some tweaks I need to do, but I literally finished it and just started recording this instantly. So the finished code might have a couple things changed for like little errors or something like that, but I mean, this should be pretty close to what the finished code will be. Ship.h. Only inclusions for this are list, iostream, and crew.h. You need to include crew.h for the ship. That's definitely for sure. You can see when we create ship, we have the distance 0, this stuff, the destructor, display, feed crew, watch movie, check crew, crew.h, crew.cpp, planet. Take a second to look at this because it looks a bit confusing. But water val is just a variable, temp variables up here, and water signs is the actual data variable for the planet. And same with this and this. These are just the temp vals. For like spinning the dice. Farm.h. Farm.cpp. Fuel chamber.h. Fuel chamber.cpp. You can see it's the same thing but slightly tweaked. So that's it for going through the code. Let's run it again and look for some errors if possible. Let's take a look at what we can find here. So we'll make 10. So let's see. Zoom out a bit too, it's a bit big. So we will send some troops to the farm. We'll send some troops to the chamber. Oh, I accidentally. Alright, send some troops to the Fort Crib and send to the chamber. Cool. So we have on that and that. So let's watch some movies. Let's check on the fuel. Still pre-fuel. We have incubation time 1. We have to wait another thing. We just passed Mars and we took some damage. So let's actually first let's get the crew back from the fuel chamber. Look, yeah, we can turn them now. Okay, no, it looks like it's all working now. Yeah. It's good to me. And see, we still have 6 on the farm, so let's try to put in 6. It should say no. We did not have enough, so 4 have been sent. Perfect. So it's all working like it should. Let's go to the farm and get the crew back. So the crew are back in the main hall from the farm. We'll go ahead and we will feed the crew now. We'll feed them, I don't know, 40. So, looks good to me. Looks like our distance traveled is 231 million miles. We should repair the ship, probably. Get some happiness up. They're a bit depressed. Let's return the troops from the chamber as well. So our fuel looks good. We need to definitely make some food, though. Send all the troops to the farm. And we will go ahead and get the happiness up. I didn't mean to click that. So, we'll do some movies. So it looks like we've traveled 510 million miles. We'll check on the planets we've seen too. We've only passed Earth and Mars thus far. Hey Felipe Quentin Tarantino, we're passing Jupiter, so now we've passed Jupiter as well. Let's return the troops from the farm. And let's feed them. Let's feed them 50. So, hunger's good, happiness is a bit low, so let's try to get that up. Ship has encountered disturbance, we need to repair it. We've traveled 1,582 million miles thus far. So we need some fuel and some food. So we will go ahead and let's put 5 in there. I'm so used to, let's put 5 in there. Let's put 5 in there. We just passed Uranus. I think that's how you pronounce it, but we just passed it. Let's see. So half's in farm, half's there. We will watch a movie. We're on day 36 in this simulation. Let's view the past planets. We passed Earth, Mars, Jupiter, Saturn, Uranus. The information. Fun fact, these are the actual gravities, and I tried to make this part accurate too on the right. So let's go ahead and get our food out of the chamber. We need to get our fuel too. Okay, perfect. So we need to feed our people because their hunger's getting low. Let's feed them 40. Approaching wormhole, get ready. Wormhole has warped space-time and took us to a new galaxy. Whoa, we're in an entire new galaxy. So I want to see actually what happens here. Let's get the happiness up because they look a bit depressed. These low numbers. Planet unknown. Approaching new planet unknown. Unsurvivable. Atmosphere 0, 1, soil 0. We'll call it Cody planet. So let's actually look at the planets we've approached. It looks like we're approaching a new one too. So we'll call this one B2 or something. Doesn't matter really. So these are the planets we've encountered. We've traveled through a lot of miles. Our food's low, our hunger's getting low, our health's good though. Fuel looks alright. But yeah, I mean that's the game. There's not really much more to show. Because the only other thing that can happen is we get lucky, the 1% or whatever, and we encounter a planet that is survivable, and it's like, congrats, you've survived the game, blah blah blah. And that's it. It's pretty neat, and it's actually a pretty fun piece of code. I think it's pretty cool. I should probably add something at the end where I just iterate through and delete the instances of pointers and whatnot, but it doesn't matter all that much. It's fine as it is because it just returns 0 after that, and it's not like I'm outputting any files or anything. I think it's pretty cool. Um, anyone who thinks it's cool, feel free to leave a comment or something, or use it, or I don't care. I think it's pretty neat. I finished it right before I made this video, and I've been wanting to make something space themed or kind of similar to Interstellar, like because I just finished the movie. So I made like an asteroid game that I thought was way too basic for my liking. Like I was not content at all with that. This is something I think is super cool though. It's got some complexity to it. Um, actually is like kind of fun. Like I just enjoyed myself and I made it. You know what I mean? So I think it's pretty neat. Um, I think it's something cool, something to look at and learn from if you're new to C++ or programming in general. So I'm gonna go ahead and end it. Uh, I might add more to this or tweak errors, but I don't see any errors really to tweak other than maybe like adding a space to. Well, I'll do it right now. I mean, it'll take 5 seconds. Let's see. Where is it? There we go. I mean, that should fix the little space issues I was having. So, you know, this crew, yeah, there we go. So that'll fix like the only thing that was wrong too, like having the number right up with the string. So, that's it for the video. I'm gonna end it. Feel free to look at this code, in the description. I'll have my GitHub linked, and do with it what you will, or tweak it, or make improvements to it, analyze it, whatever. It took me about 2 hours to make, and it's pretty neat. So I'm gonna go ahead and end it. God bless. Everyone have a good day, a good night, a good evening, a good afternoon, a good morning, whatever time it is you're watching. And that's all. Peace.